Okay, I'm Indira Bandari, and today I'm going to show you what happens when Power BI meets Azure Machine Learning. Thanks to the sponsors, SQL Relay and Power BI User Group Belgium, for inviting me to speak at this webinar. Wouldn't it be great to visualize the Azure Machine Learning model inside Power BI? More so when you operationalize your model through the Power BI service. Imagine if you could show your management team the output of the sentiments for the recent tweets about your products, for example. So let's go over the agenda today. A little bit about me, followed by what is machine learning, a high level definition, machine learning categories. I'll cover machine learning categories and machine learning algorithms, just a high level classification of machine learning algorithms, what Azure machine learning is, and also what Power BI is at a high level. And most of my session will be end-to-end demo of creating a model in Azure machine learning, and then getting some visualizing that in Power BI. So let's get started. I have a master's degree in statistics, and I'm very passionate about data analytics, and I have over 15 years of experience in designing and developing data warehouses and analytical solutions. And I'm very much interested in data science and machine learning. I speak at local user groups and meetups where I live here in New Zealand, and also a co-organizer of one of the meetups and SQL Saturdays here. And I have a I'm very passionate about volunteering and sharing my knowledge to the community. And I started 2 years ago. I started teaching kids, primary school kids. First, I taught game development, and from this year, I started teaching databases and data visualization concepts to 11 to 16-year-old kids. And my contact details, I think you all can see. Moving on. So, what's machine learning? For those of you who don't, first of all, a little bit what machine learning is. It's an idea to learn from examples and experience without being explicitly programmed. So instead of writing code, you can feed data to a generic algorithm, and it builds logic based on the data given. So how is it different to artificial intelligence and deep learning? So I have given a visualization here. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. So moving on, what are the machine learning categories? There are broadly 3 categories of machine learning, which you can say supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, how it works is this algorithm consists of a target or an outcome variable, which is to be predicted from a given set of predictors. So the predictors will be independent variables. So using these set of variables, we generate a function that map inputs to desired outputs. The training process continues until the model achieves a desired level of accuracy on the training data. Examples of supervised learning are regression, decision tree, random forest, KNN, and logistic regression, etc. Coming to unsupervised learning, how it works is in this the algorithms, we don't have any target or outcome variable to predict or estimate. but it is used for clustering population in different groups, which is widely used for segmenting customers in different groups for a specific intervention. For example, one of the examples is k-means, which is widely used is k-means clustering algorithm. The third one is the reinforcement learning. How it works is the machine is treated to make specific decisions. It works this way: the machine is exposed to an environment where it trains itself continually using trial and error. The machine learns from past experience and tries to capture the best possible knowledge to make accurate business decisions. Example of this is Markov decision process. Now, coming to machine learning algorithms, the most common machine learning algorithms can be grouped into 4 categories based on what you're trying to achieve with your data. So as this visual, I got it from askaswiss.com, and what this visual is trying to say is, if you're trying to predict categories, then you use the classification algorithm. If you are trying to predict values, then you are using the logistic regression or linear regression algorithms. And if you are trying to discover the structure, you are using the clustering algorithms. And finally, when you're trying to find unusual data points, then you use the anomaly detection algorithms. Okay, in terms of what we are going to cover today is about Azure Machine Learning and Power BI. This is a visualization from Microsoft. So here you can see machine learning and Power BI in different areas where the data becomes intelligence and intelligence becomes action. So what is Azure Machine Learning? Okay, Azure Machine Learning is a service, and it can be considered as a platform as a service, or a and is cloud predictive analytics service provided by Microsoft. And Azure Machine Learning Studio is where you build your machine learning applications, and it's a very useful tool with a drag and drop feature to create your experiments in the cloud. And Azure Machine Learning have a lot of algorithms that you can use, readily available algorithms that you can use to create your model. It's a very easy to use platform to make predictions, and I hope you will like it when I try to show you what we can achieve from Azure Machine Learning. And what is Power BI? Power BI has evolved a lot in the last 3 years. There is a Power BI desktop and Power BI on-premise reporting server, which can be used for on-premise. And then once you do the development in Power BI desktop, you can just publish onto the Power BI service, and these reports and dashboards can be used using a Power BI mobile app as well. And there are different levels, different sources that you can get data from into Power BI. And there is a Power BI gateway as well, where you can use the data from databases and SQL Server analysis services. And there is also Active Directory that you can use on this that you can sync between the on-premise and also cloud. Now, coming to the workflow that I'm going to show you today is from if you create your model on Azure Machine Learning and train it so that and then once you are happy with the model, you can operationalize it, and then use the R code to get the results of the model into Power BI. this R code that you can use is can be used as a stored procedure, and call the stored procedure from the SQL server, on-premise SQL server, and then that way you can predict the values, and then visualize those predicted values in Power BI. That is the workflow that I'm going to show you today. The data I have used, I'll be using in my demo is Titanic data from Kaggle. The link, I have given the link here, and we are going to predict survival of the passengers in the Titanic. The prerequisites are, you need to register at studio.azureml.net. And you need, if you are just trying to learn on your own, you can use SQL Server Developer Edition, and also install Microsoft R client, and also to analyze the code and make the changes in R language, I used R Studio, and also install the latest version of Power BI Desktop. Other prerequisites, these are the things that I thought are useful, because when I was trying to do the demo, I had some issues, so that's why I put a couple of screenshots as to what is actually required. So you need to create a ODBC connection to connect from R to the on-premise SQL server. So when you create the ODBC connection, in order for you to use the SQL authentication in the R code, you need to run the database in mixed mode, which is the SQL Server and Windows authentication mode. So that is one of the things that you need to do after installing the SQL Server Developer Edition. And also you need to enable the TCP/IP protocol in the client protocol and name pipes in the SQL Server Configuration Manager. Those are the two things that you need to do before you start anything else. Okay, now coming to the demo. Okay, so if we go to Studio, I'll first show you the Azure ML part. So if you go through the Studio, so I have created my experiments. I have already signed in, so that's why it's showing my experiments. So I'm just working in launching my experiments, and then you can either type here for a let's say I am doing a Kaggle Titanic data set. So there are some experiments which have been done by other people, so you can search for that. For some reason I think this is not coming. So this is the experiment I have utilized. So the Titanic dataset is the dataset which has which was imported from the CSV file from the Kaggle website. Here it is there on the data. In data you can get the test and train. I just use the train CSV, so which has all these variables. So this is this file that I used. It has 891 rows and 12 columns. So when you visualize the data set, you can so the Azure Machine Learning workspace, if you create a blank experiment, you just get a shell of the model that you can create. Now this is what I'm showing you is a created model. So first thing that you do is you import your data set. So once you import, you can actually right click and visualize what your data set contains. So it contains same as Titanic data set that was provided in Kaggle website, 891 rows and 12 columns, and you can actually see the statistics of each column that you have used, how many have survived, and this is passenger class and what the names are, and what the gender is, age, and you have a fare column and ticket, embarked, and the port of embarkation and things like that. And what I did in the first step after importing the Titanic dataset is uh, I dropped a few columns which are not being used in my model, because the column, you can drop it by launching the column selector, and you can specify exclude column names, or you can say just include column names. What I have done is I have excluded passenger ID, name, cabin, and ticket, because those were ticket I have excluded because a lot of nulls are there, and cabin also a lot of nulls which we don't need. So I have excluded, and name doesn't mean anything when you are trying to analyze this particular model. So I have excluded those. And the next step, what I have done is did some transformations. So I made these survived passenger class, gender, and uh, port of embarkation as categorical. And the next step, what I did was uh, these ones, I just renamed the columns to sibling, spouse, parent, children, and parent, child, and fare price instead of just fare. So those are the just renames. And then the next ones is missing value. I use the missing value scrubber. So all these tools that I'm using are available here. So for example, if you want to say missing value scrubber, uh, so here this is the tool that I used, and it's just a drag and drop interface. So you just drag it, and then you can specify what your missing values can be substituted with. You can either remove the entire row, remove the entire row, or you can replace it with median, or whatever you want to do, you can do that with using the missing value scrubber. And then I just assign the data target variable has survived. So this is because that is what we want to predict. So that's assigned as the target variable. And then before we start with the algorithms, we need to split the data into train data and test data. So what I have done here is I have split the rows based on a 70-30 rule. So 70% will be taken for training the model, and the rest 30% will be used as test cases to predict the target variable. And the algorithms that I have used is two class boosted decision um, algorithm and two class decision forest algorithm. So what is a two class boosted decision algorithm, decision tree algorithm? It's a learning method where it has a lot of trees, like it's trees, and so each tree, the second tree corrects for the errors of the first tree, and then the third tree corrects for the errors of the first and second tree, and that it continues. So the fourth tree corrects the errors of the first, second, and third tree. So predictions are based on the entire ensemble of trees together that makes the prediction. And the decision forests are the two-class decision forests are fast supervised models, and this module is a good choice if you want to predict a target with a minimum of maximum of two outcomes. So that's the reason I picked this one. And then use the split data to run through both the models, and then so this is the training the model, and this is where you are scoring the model. So when you are scoring the model, the test data comes. If you look at the link, the test data comes from the split. Here also you are scoring the model, and then finally you evaluate the model. And when you are evaluating the model, so you can actually check, visualize the results in the evaluation, and then see which one is performing better. So for example, if I selected this one, so I selected score data to compare. So if you see the statistics here, it's having 83% accuracy, and that one is I think 80%. So the red one is more accurate, at least a little bit better than the scored data set. So we can use that to predict the model. So once you are happy uh, with the statistics of the model, then what you can do is uh, you can click on setup as setup web service, and then you can click on update predictive experiment. I'm not going to do that now because I have already built a predictive experiment. So when you look at the my predictive experiment, so it comes like this. It comes up with a web service input, and and then I have done a couple of modifications before deploying this as a web service for us to use. So what I have done is I have dropped the column survived, because that is what we are going to predict. So I have dropped the column survived here, and then I have selected columns. After scoring the model, I have selected columns in the data set to include only three columns. If you look at the column selector, I have asked to select on to show only passenger ID, scored labels, and scored probabilities, which I am going to use for so that will be the output of the web service when we use it. So that's how you can once those modifications are done, what I've done is deploy the web service. So once you deploy the web service, you can go here. Here there is a web service, and then here, if you click on that, it launches a page where there is an API key given. So you can use this API key, and also if you click on the request response, this generates a request header, and then it generates a sample request and also sample response, how it will be, because we have chosen passenger ID, score labels, and scored probabilities. We'll get 3 columns as the output, and at the end what happens is you can actually see the sample code, C# code, Python, and R. Now you can use Python also with Power BI, but today I'm going to show you more on R. So you can select this R sample code and then use that in the Power BI. So that's how Azure ML is used to deploy create a model and deploy as a web service. Now I'll go to the SQL Server, and this is my SQL Server on-prem on my laptop, and I have created a database called Titanic, and I have a couple of tables here called passengers and survivals, which I am using. So I'll show you how the passenger table. What I have done is I have downloaded the trained CSV dataset from Kaggle, and then converted that into Excel, and then just imported that into this table. And the column structure of this is I can just show you. So this has passenger class. I just removed the survived here. Passenger class, names, gender, all those extra are there except the survived column. And then I have created a survivals table, which is which is the copy of the output that we have generated. So if you look at the columns, there are only three columns: passenger ID, scored labels, and score probabilities. So this is what you can do here. And now this is the setup of the database that I have created. And now I'm going to launch Power BI, and I'll get you to look at the model here. First, I'll go to the relationship. See, this is the passengers that is straight from the on-prem SQL Server, and this is the survivals table, and these two are linked by passenger ID, so that you can see what the scores who survived and who did not survive with, and with what probabilities. And these two data sets that you are seeing here, those two are the data sets that are created out of R. Now to do that, to create these two data sets in Power BI, what I've done is I have copied the R code from here, from the web service. Yeah, I have copied the R code from the web service, and then did a few modifications in RStudio. So as I mentioned earlier, the prerequisite for this thing is one of the prerequisites is installing Microsoft R Client and RStudio. So once you install RStudio, what you need to do, RStudio and Microsoft R Client, one of the first things that you need to do is in Tools, Global Options, there is something for there is this one here, where you specify the R version. So the R version that I'm using for RStudio is here, Microsoft R Open. Most of the sometimes if you have multiple versions of R, then you have to choose this one, because I have multiple versions of R here. So I chose the Microsoft R client only here. I have a lot of other versions as well. So that's one thing that you need to do before you start. Otherwise, you might be having a bit of a problem because you need to install this library, and with the Microsoft R client as the R package, you don't face that much problems. So once you install that, what I have copied the code, and that code starts from I think here. Let's go and that code starts from these two libraries. I have added these two because RStudio was giving a error. So when I'm connecting to the to the on-premise SQL server. To connect to the on-premise SQL server, you need RODBC package. So I have to install that. And then I have added these 3 lines of code. What these lines are showing is we are connecting to the ODBC connection that I have created. Okay, I have to show you that as well, I think. I have created a ODBC connection in here as a the name of the ODBC connection is developer, and also I created a SQL Server user called with the username and password. You can actually, if you do all this in the store procedure, then you don't need to specify explicitly specify password. That is when you are trying to um, operationalize and um, create an enterprise version of visualizing your Azure model into Power BI, then you can use some store procedures and do it that way. And so I have created a data set, and then I'm creating a data frame with a particular query. What I'm trying to do is here is select all the information from passengers where I'm giving some conditions to just exclude all the nulls. You can do that or you don't need to do that. But the main condition that I'm giving here is find all the passengers that are not there in the survivals table, so that I score only the new passengers instead of scoring all the passengers that I'm trying to predict. And then you can immediately close the connection. And then I have also added if the data frame is has any values, only then go and uh, score the model in Azure ML. Otherwise it doesn't need to score the model in the Azure. And all this I haven't changed anything except for the copying the API key from the Azure Machine Learning. I'll show you from where to copy. So here, when you go to the web service, this is the API key that you need to copy and then paste it here. And this automatically comes up in the R code. So I didn't make any changes here. And yeah, and then I have okay, one of the things that I faced when I tried to execute this code was when I tried to pass the data set, that the data frame that I created to Azure ML with this list of columns. Because I had the survived column there in that passenger table, it was giving an error called bad approach, because the number of columns didn't match what it was expecting. So I could have done it by removing the column in R itself, but I just did it by removing the column in the data set. So you could have used something like remove the second column and the fourth column and the fifth column. That also you can use, or remove the second column, something like that, and then you can use that. Once I did that, I think I was pretty good. So, and then so till here the R code is given in the Azure ML service. From here, I have added to create a Titanic final dataset, because Power BI does not recognize lists, so it has to be created as a data frame. And then from there, I have created whatever is there in the Titanic final. Titanic final has the last, because the web service outputs the 3 columns: passenger ID, scored labels, and scored probabilities. So those are the things that will go into the, so this code actually connects this SQL server and then saves the predicted values into the survivals table and then closes the connection. So once you use this R code, then you can use that. Now I'll go into Power BI and then show you how I have imported that. So if you go, I'll just take you to edit queries, and then if you go on new source and then more and other and then R script, and then you can just copy the code that you have here. Oh, so the R code can be copied from here and then here. Um, so once you do that, see here also you can see the script will run with the following R installation. Make sure that that is there. And also when you say OK, then what happens is you can see the two data sets that you have created. You can see the data set called dataset here, and also the Titanic final, which I've created that to be, yeah, those two. So those two are the data sets that you can see now here. I just said new data and Titanic final. So now what I'm going to show you is I'm going to insert 3 rows into I'm just going to go into my insert script, and then see my insert script. I'm inserting 3 rows into passengers table. One is let's say Donald Trump. Let's say somehow he went back in time and then boarded the Titanic ship in Southampton. And Bill Gates, he also boarded in Queenstown, Ireland. And Jacinda Ardern, who is the New Zealand Prime Minister, she also somehow went to Queenstown and boarded the ship. So let's see. I just want to predict these 3 to see whether they survive or not. So I'm just going to insert these. So you can see 3 rows affected. And now I'm going to go to my Power BI model, and then I'm going to just refresh it. Hopefully this works. See, you can see passenger count 892. The last recent passengers that I have added is 2, and have shown the average age of the passengers 29.44, and I'm visualizing by who survived and who was scored. You could also maybe use the actual survived data and then maybe compare actual and predicted. I didn't manage to do that. And passengers by gender, passengers by who embarked in what port. And now I'll hit refresh. So now you can see there are 3 new passengers and to be predicted, and these are the names of the 3 passengers. And yeah, so from here, so when you look at the relationship from the, now you understand a little bit more now of the data. So passengers is the table straight from the SQL server. Survivals also is straight from the SQL server. I took Titanic final, which is the similar to the survivals survivals table in the SQL server, and this is the new data that is that has been picked up from the SQL server to be sent to the to Azure ML, and this is the predicted value. So if you visualize Titanic final here, oh yes, so it should have yeah, it has the scored probabilities, and then So if you and also I have created some drill throughs here. So if you look at how many mails have if you want to know mail passenger details, so you can see mail passenger details embarked in all ports, and then how many have survived and how many mail passengers are there. Similarly, if you go back and look at let's say, for example, port embarkation, let's say drill through, and then look at all genders and Southampton port. So 153 survived and 645 passengers total boarded at Southampton. So this kind of visualizations can be done through Power BI, and it can be set up to refresh as and when you like, and um, based on your requirements. And this can be published to the Power BI service and can be actually viewed on mobile apps as well. So that's the end-to-end demo, and I would like to just have a recap of what I've shown. So the recap is, so first download the dataset from Kaggle, converts the CSV file to Excel, import the data into SQL Server, and create another table to store the score labels and probabilities along with the passenger ID. Create an ODBC connection to the SQL Server and the database, and log into machine. You can do these steps first, and then log into the Azure Machine Learning Studio and create your experiment, and keep trialing with different algorithms that are available in Azure ML. And once you're satisfied with the output, then you can create a predictive experiment, and then that predictive experiment also you can make some changes regarding the outputs and inputs, because I think you need to remember to not have the target variable in your predictive experiment. You can have it, you have to have it in your experiment that you are trying to um, uh, learn, trying to let the experiment learn, but not in the predictive experiment. And once you have done that, you can deploy that as a web service, and then you can use the R code that is generated by the web service on Azure ML, and then do the necessary modifications, not minimal, not too huge, and then include that code in the SQL Server score results of the SQL Server table at the end. And then you can create a Power BI model in the Power BI desktop using the R script, and then also import some tables based on your requirements of what visuals you are trying to convey to the user. And once the data is ready, you can get the data from the SQL Server as well if you want, and then start visualizing as to who will survive and who will perish. So that's in a gist all the steps that can be taken, and I have put some references here and some useful links, particularly when you are trying to run your R code in R Studio. There will be some, if there are some errors that you face, there are some error codes in this link which give you some insight as to how to resolve the errors. I have found it very useful, so I thought people will find this useful. And yes, that's all from me, so we can head for questions.
Well, I enjoyed the presentation. It turns out
Thank
so
you.
far nobody has any questions. If anybody has one, now is the time to ask them. You should have this question box down below where you can type any question. Yeah. Turns out nothing is coming in.
Okay, I hope you all enjoyed the presentation, and if you have
Yeah.
any questions, my details are there, so you can my details, I can share them now. Yeah, my details are here on the screen. So I on Twitter and LinkedIn
Okay.
in my email.
Well, thank you once again for doing this, Indira. I really
Thank
enjoy
you,
your
Jan.
presentations.
Thank you.
Um, I hope to see you next time.
Yeah. Okay. Thank you, Jan.
Thank you. Good evening over there.
Yeah. Good night, actually.
Yeah, good night. Yeah.
Okay. Okay then.
Okay. See you.
Okay. See you. Bye.